welcome back to the QST YouTube channel. Today we will be solving the chapter 5 in physics from 5.1 to 5.4. Okay, let's go. James has a mass of 80 kilograms. If he stands on 1 foot and the area of his shoes is 200 centimeters squared, then the pressure exerted by his foot on the ground is... Okay, first of all, we need to... Pressure is force over area. The area we have is 200 centimeters squared, but we're gonna have to make it meters squared. So we're gonna have to do 200 divided by 10,000 to make it into meters squared. So 200 divided by 10,000 is 0.02. Okay, and now the force, which we know is weight, we can do by doing mass times gravity. So we can simply do 80 times 10, which is 800. And then after we do 800 over 0.02, we get that the pressure is 40,000. Okay, question 2. When a man stands on the floor with both feet, he exerts less pressure when he is standing on 1 foot. This is because when he's standing with both feet, there is more surface area which makes the pressure less. Number 3. A juice box of mass 1 kilogram and dimensions 8 by 8 by 13 centimeters rests on a table as shown in the diagram below. Okay, first of all, in part A, they want the force. To find the force, we're gonna have to do the mass, which is 1 times 10, which is g. So it's 10. Okay. The pressure exerted by the box on the table to two decimal places. Okay. First of all, we need to find the area of what is causing a force on the table. The part that's causing a force on the table is this rectangle. We know that this part at the bottom is 13 and this is 8. Okay, so to find an area of the rectangle, we're gonna do 13 times 8, which is equal to 104. Okay, so now we're gonna have to convert centimeter squared to meter squared by dividing by 10,000. So that will give us 0.014. Okay, so to find the pressure, we're gonna have to do the force over area, which is 10 over 0.014, 0.0104, sorry. Okay, and that will give us 961.5. But here they said they wanted it in kilopascals. So, to make it into kilopascals, we're gonna have to divide by 1000, which will give us 0.96. Okay. Part C. The force exerted by the box on the table will remain the same because at the end of the day it's still the same mass. It's still gonna be the same mass, which uh, which is 1. So which means the force will be the same. the surface area will decrease because as we can see here, the area that is pushing the table downwards or like giving the table a force downwards is more comparing it to here, which is why the surface area will decrease. So, okay, the pressure exerted by the box will increase because we know that, wait, force over area is equal to pressure, right? Okay, since area is like not at the numerator with force, uh, that will make the surface area inversely proportional to the pressure, or the pressure inversely proportional to the area. So let's say if pressure increases, surface area will decreases, and vice versa. While on the other hand, the force, if the force increases, let's say, the pressure will increase, and vice versa. Question 4. The pressure is measured pressure by a pressure gauge. Liquid pressure can be measured using simple gauge called U-tube manometer. Number 5. A force of 5 newtons is applied to a piston of a syringe filled with water. The length of the syringe is 3 centimeters and its cross-sectional area is 2 centimeters squared. Okay, so first let's find the area of, the pressure at B because it's easier. So to find the pressure at B, we're gonna have to do 5, which is the force, over the area 2 centimeters squared. But we're gonna have to make it into meter squared. So we're gonna have to do 2 divided by 10,000. Okay. Sorry for the bad handwriting. Okay. So we're gonna have to do 2 divided by 10,000 to convert from centimeter squared to meter squared, and we'll get 0.0002. Just wait. 0.0002. 5 divided by 0, which will give us 25,000 pascals. And from pascals to kilopascals, we divide by 1,000, which will give us 25. Now to find the pressure at A, we know that if there are 2 points at the same horizontal line from each other, they have the same pressure. So the pressure at point B, which is 25 kilopascals, will be the same as point A. So which is why the pressure at point A is also 25 kilopascal. Number 6. In a liquid of density ρ, the pressure due to the liquid at a given depth is ρgh. Rho is a Greek letter for R, you can say, and it also stands for density. Number 7. The density of seawater is 1020 kilogram per meter squared. The maximum depth of the Atlantic Ocean is 85 kilometers. Okay, so as we said, the pressure is density times g times height. Okay, density is 1020 times 10 times 8500 because we're gonna have to convert kilometers to meters times 8500. Okay, which will give us 86.7 million. But here they said, wait, sorry, my microphone cut. Anyways, what I was gonna say is, how can I name this? Is that we're gonna have to add 10 to the power of 5 because they said the pressure. So we're gonna have to add atmospheric pressure, which is 10 to the power of 5 or 100,000, which will give us 86.8 million. But here they said they wanted, well, they wanted it in megapascals. 6, then 8, 0, 0, 0, 0, 0. Okay, so now they want it in megapascals, which means we divide by 10 to the power of 6. So 1, 2, 3, 4, 5, 6, and we get that it is 86.8 megapascals. Number, eh, number 8. The pressure due to water at the crush depth of Seawolf okay. A crush depth is the maximum depth a submarine can submerge without getting damaged. The crush depth of Seawolf class submarine is about 730 meters. The density of salt water is 1020 and then the G is 10. Okay, as we said, we use rho G H to find the pressure. So we're gonna do 1020 times 10 times 730, which will give us 7446000. Okay, here they said they also wanted it in megapascals, so we multiply by 10 to the power negative 6 or we divide by 10 to the power of 6. 1, 2, 3, 4, 5, 6. So the answer will be 7.45 megapascals. Number 9. As depth increases, the pressure in a liquid increases. Now look in the rule, rho GH is equal to pressure. Everything is directly proportional to pressure except gravity because it stays constant, it doesn't change. Okay, number 10. The cross-sectional area of a shoe's heel is 150 centimeters squared. The weight of the person wearing these shoes is 600 newtons. Okay, so as we said, pressure is force over area. Here they gave us the pressure, I mean the area of one shoe, because this now they want, how can I say it? Uh, it's gonna be two shoe, like the person is standing on 2 feet, not 1 feet. If they didn't specify, that means the person is standing on 2 feet. So that means the area that's interacting with the floor is 300 centimeters squared. But we're gonna have to convert that to meters squared by dividing by 10,000, which will give us 0.03. Okay, so we're gonna do 600 over 0.03, which will give us 20,000. Okay, and since they wanted times 10 in scientific notation, so we just um, since they wanted to times 10 to the power of 4, we just divide by 10 to the power of 4, 2, 3, 4, and we get that it's 2. Okay, question 11. Why does it skip to question? Okay. A diver of mass 70 kilograms swims in the salt water of density 1020 kilogram per meter cube. The diver is 5 meters below the surface of water. Okay, so now we use rho GH to find the pressure. So we're gonna do 1020 times 10 times 5, which will give us 51,000. And since here they wanted it in kilopascals, we divide by 1,000, which will give us 51. The diagram below shows a hydraulic press. The downward force exerted on the 4 cm squared piston is 20 newtons, and the area of the other piston is 50 centimeters squared. For this question, there is a really easy way to solve it. We can just cross multiply. So 20 times 50 is equal to 4 times, let's say, P, which is, or actually let's make it F to make it easier. So 20 times 50 is equal to 1000. 1000 is equal to 4F, and we'll find out that F is equal to 250. Number 13. The plunger sticks to the surface of the floor under the influence of atmospheric pressure since the pressure outside the sucker is greater than that inside. Number 14. Wait, let me just make sure. Did I put? Okay. The plunger sticks into this. Sorry guys, I accidentally used my answer. The plunger sticks to the surface of the floor under the surface of the atmospheric pressure since the outside pressure since pressure outside the sucker is greater than, not less than, greater than the inside. A boy is drinking soda through a straw. The cup is exposed to the atmosphere. Which of the following are true? The pressure inside the straw is smaller than the pressure outside at the same level. The difference in pressure causes the liquid to be pushed up the straw. If a hole is made in the straw, it would be impossible to drink through it. Number 15. If a fluid is open to the atmosphere, its surface will be acted upon by what is known as the atmospheric pressure. Number 16. When a vacuumized tube A of radius 1 centimeter is placed into a bucket of mercury, the liquid rises into in the tube to a height of 800 millimeters. Okay. If another vacuumized tube B of radius 2 centimeters is placed into the same bucket of mercury, the liquid will rise to the same height. The height will not change. Okay. Number 17. The what is the okay? So this is a barometer which measures atmospheric pressure or pressure due to the atmosphere, and the unit or like that is used to measure to measure the pressure with this instrument is in millimeter mercury. Number 18. The instrument shown in the diagram is a closed end manometer because look, as we can see here, it's closed. So like if it's closed, that means it's a closed end. Okay. So first of all, we're gonna have to convert uh, grams to cent. Oh yeah, my bad. The value of pressure of the gas is what? Okay. First of all, we're gonna have to convert 13.6 grams per centimeter cube into um, into kilograms per meter cube by multiplying by 1000. And don't forget that the rule is rho whatever g h. So 13,600 times 10 times the height, which is, we're gonna have to add the heights here, so it's gonna be 5 centimeters, but we're gonna have to convert it to meters, which is 0.05. So 13,600 times 10 times 0.05 will give us 6,800. And since they want it in kilopascals, we just divide by 1,000, and that will give us 6.8 kilopascals. Number 19. Rank the following setups according to the pressure vessels A through E. Assume that all liquid in the... Okay. Okay, so first of all, the ones with atmospheric pressure will always be the highest. So C, B, and E will be the highest. And to figure out which one's the highest between each one, we're gonna have to use the difference between the heights, which in C is the highest. The highest the difference in height between the two like sides of the tube, it means that pressure is higher. So C is the highest pressure. B has less pressure, and C has even lower because, as we know, as I just said, it has like the least difference in height. Okay, and then since we know open-end atmosphere, like open-end barometer or manometers will have higher pressure, now we're gonna move on to closed-end manometers. We're gonna use the same way I used before with the difference of the heights. The higher the difference of the heights, the higher the pressure. So here, this is why D has higher pressure than A. Number 20. In any container, a liquid will always form a uniform level. In connected vessels, a liquid settles at the same level irrespective of the shape and size of the vessels. By pulling a syringe, a partial vacuum is created. The higher the pressure outside the syringe pushed the fluid inside. The bicycle pump is a mechanical device that moves a fluid by pressure or suction. Number 21. The instrument shown below is a hydraulic press. Okay, now here we're gonna use the same. Given the downward force exerted on the 20 centimeter squared piston is 12 newtons and the upward force on the other piston is 36 newtons, the area of the other piston is what? Okay, so as I've done before, we can just do the force of one piston times the area of the other piston. So we're gonna do 36 times 20, and then we're gonna divide by the force of the first piston, divided by 12, which is 60. Number 22. An open-end manometer is an instrument used to measure the difference between the pressure of a gas and atmospheric pressure. A closed-end manometer is an instrument used to measure the absolute pressure of the gas. Number 23. Consider the closed-end manometer shown below. Okay. The liquid in the tube is mercury, density 13.6 grams per centimeter cube. Height 1 is 15 and pressure is 30,000 kilopascals. Okay, so first of all, we know that the rule is rho g h, right? But h here is height 2 minus height 1. So it's gonna be this part. Okay, so we're gonna do 30,000 is equal to 13,600, which is the density, but we're gonna have to convert it to kilometers per, yeah, kilograms per meter cube times 10 times height 2, which we don't know, minus 0.15. Okay, so then we're gonna distribute 30,000 is equal to, okay, so 136,000 height 2 minus 136,000 times 0.15, which is 20,400. Okay, so now we're gonna have to take 20,400 to the other side, which will give us 50,400 is equal to, I think I made a mistake. I think we should remove 10, then 10 here is equal to 136,000 height 2, and then we divide 50,400 divided by 136,000, which will, okay, so what is it? So it turns out this has an extra zero. I made a calculation mistake, sorry guys. So this will have an extra zero and we'll get that it is 37. Okay. Question 24, which is the final question. A battery hydrometer allows a mechanic to measure the density of a liquid inside a car battery. In order to collect the liquid sample, the rubber head is squeezed, the glass tube with a small opening is immersed into a liquid, and then the rubber head is released, filling the glass tube with the liquid. Assume the density of the liquid is 1200 or 1.2 times 10 to the power of 3, and it forms a column of 15 centimeters in the hydrometer. Okay. When the rubber head of the hydrometer is squeezed, the pressure of the air is lower than the atmospheric pressure. When the rubber head is squeezed, the pressure of the air inside the hydrometer, okay, since we know that the pressure in a liquid is rho gh, so we're gonna use 1020 times 10 times 0.15 because we're gonna have to convert 15 centimeters to meters. Okay, which will give us what? I mean, wait, my bad. It's not 1020. It's 1200 here. And this will give us 1800. And to make it from Pascal to kilopascal, we just divide by 1000, which will give us 1.8 kilopascal. Thank you guys so much for watching this video. I wish you guys the best of luck I wish you guys the best of luck in your final. And thank you and goodbye.